Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Luke. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right. How you feeling?
Good.
That's the most difficult thing you're going to do all day. You got through it already, right?
Yeah.
There you go. All right. So, Luke, where do you attend school and what grade are you in?
I attend school at Highgate Elementary, and I'm in 6th grade.
How is 6th grade?
It's good. I like it. I think I like 5th grade more. But
Why?
I don't know. I like 5th grade, but the math was easier in 5th grade. Everything was easier. So.
Well, everything you learned in 5th grade, you're going to do in 6th grade. You're just going to do a little bit more advanced problems, right?
Yeah. Yeah.
Because didn't you learn a lot of fractions, decimals, and percents in 5th grade?
Yeah, and now we're doing it now.
Right, you're doing it now. Guess when you're going to do fractions, decimals, and percents again?
Probably 7th grade.
Yeah, you got it. And when do you think you're going to do
right
it after
now.
that?
8th grade.
Yeah, you got it. When do you think you can do it after that?
High school, 9th grade.
Ooh, you got it. You're going to do it for the rest of your life, fractions, decimals, and percents, right? So the sooner you get them and the better you understand them and the more advanced you can get with them, the easier everything is going to be for you a little bit.
Yeah.
All right. Are you looking forward to Camp Keep? Do you guys go to Camp Keep at
Yeah,
your
we're
school?
gonna go to Camp Keep. I'm not sure when, but we're gonna do it sometime.
Yeah.
This year.
Have you
so-
heard anything about it from other kids that have gone?
Yeah, they said it was fun. They said they just liked all the the science they did.
Yeah. So there's a lot of science activities. You're outside for a whole week. You're
Yeah.
away from your parents. You know, like right.
Yeah.
You love your parents, though, right?
Yeah.
Yeah, I know. But it's always fun to go away for a week, right? Go out, hang out with your friends for a week outside at the beach and stuff like that.
Yeah, it is. It's nice, probably. I'm
Yeah.
excited to do it.
You're going to love it. Dude, I'm telling you, you're going to remember it for the rest of your life.
Yeah.
All right? You ready to do a math problem?
Yes.
All right, let's take a look at the social media problem of the day. So we have 8 divided by, now how do I read that? Because I could say 0.2, but is there another way to say that properly mathematically?
0 and 2/10.
Good, 0 and 2/10. So taking a look at the different options that are up there, are there any that you think we can eliminate right away?
We can eliminate 4 because we know 8 divided by 2 would be 4.
Okay, and you
So-
think that's why they put the 4 up there, because it looks like 8 divided by 2 if you look at it quick?
Yeah.
That's probably why it's up there. All right, what else do you think we can get rid of?
Probably the 40.
Yeah, because it would be, I mean, not impossible, but 8, and you're going to divide it by 2/10, right?
Yeah. Yeah. Probably not.
Yeah. All right, so what do you think? How are you going to do this problem? Because we're not going to write anything out, we're just going to think about it.
Yeah. So 8 divided by 0.2, we could times 2 by 10 and 8 by 10, and we'd get 80 divided by 2.
Which would be 40.
40. Yeah, it would be 40.
So you could do that.
Yeah.
What do you think? Because you said you wanted to eliminate 40. I was like, all right, well, you could eliminate 40 if you want. So the only thing we haven't talked about is the 6 and 16. Why do you
Yeah.
think 6 wouldn't work?
Well, you can never do something with 8 and 2 to get 6, really.
I can go 8 minus 2 and get 6, can't I?
Yeah, that we're not talking about
Subtraction,
subtracting
though, right?
here.
Okay, good.
And 16, it would be 8 times 2, but it's 8 divided by 2/10.
Okay, so if I
It's a
have
lot
2/10, how many of those would I need to make 1?
you need 5.
Right.
Because 2 times 5 is 10, and that's
One whole.
one whole.
Right.
One whole.
So do you think your 40 might work if we need
yeah.
8 of them?
Yeah. Yeah.
All right, you feeling pretty good?
I'm feeling good.
You'd like to bet on that?
Yes, I would.
You'd like to bet a lot on that?
Yes.
Cool, all right, there you go. That's why I like confidence. Let's see if the young man is correct. C40 is it. There you go. Dude, I thought you were going to eliminate thing at the beginning, and then it's like, no, you're going with it. Right? Just think a little bit about it, right? Because when
Yeah.
you said take 2 and turn it into 20,
Yeah.
and then turn the 8 into 80,
I
right?
realized
Turn,
that I was
the
wrong.
point 2 into 2, right?
I realized I was wrong in the beginning. So.
That's all right. That's why you take your time with it. Think a little bit first, right? So we're going to make you do a little bit more work later on. You ready for that?
Yeah.
All right. Well, first, we're going to take a look at today's Math in the News. All right. Well, today's Math in the News, we are fortunate enough to have in studio with us Ryan Murry. How are you?
I'm doing well, sir. Thanks for having me.
Thank you for coming down. I know that you are an employee of the Kern County Superintendent of Schools.
Yes, I am.
All right, and you are with the Kern County Community Reading Project. Is that part of your regular duties here with this office?
Yes, it is. It's part of my regular duties. The rest of my duties are related to being an English language arts coordinator. I go to different schools. I provide professional development to teachers. I model lessons for students, and I just help out as much as I can.
All right, so how long have you been doing that position?
So I've been in this position since January of this year. Prior to that, I was a principal with the alternative education program here with Kern County Superintendent of Schools. And I did that for about 8 years. And if we want to go way back, before that, I was an English language arts teacher out in Shafter at the junior high.
All right,
Some of the happiest years of my life. It was great.
good. You want to keep going back in time? What were you doing before that?
Prior to that, I worked at Garces. I taught Garces for a couple years as an English teacher. Before that, I worked at Dollar Tree.
All right, so we'll stop there. We'll
Sure,
go
that's
with your
fine.
English language arts
That's
profession
great.
career, and we'll go from
That's
there.
fine. That works for me.
And a lot of people might be wondering, well, you know, this is called Do the Math. Why do we have the ELA guy on here, right?
Sure.
You've got an activity coming up where you're going to be looking for volunteers, correct?
I sure do,
And that's
yes.
coming up in October. So tell us a little bit about that.
Yeah, so October 3rd, I'm having a training for our community reading project. I'm looking for volunteers. And what my volunteers are going to do is they're going to work with second graders. They're going to go to second grade classrooms, and they're going to spend an hour each week. And they'll work with 4 different students for 15 minutes with each student. And the student will read to the volunteer, and the volunteer will kind of coach them along and kind of guide their reading as well, and to help them improve their reading.
Now, if somebody wanted to volunteer, you're obviously going to train these people on how you want them to do this when they go into a classroom.
Correct.
And do they need to select books? Are they books selected by the school, by the student? You guys provide them? How does that work?
The books come from the teachers.
Okay, so the instructor at the school will let the volunteers go, hey, this is what the kid's going to read. And how long do they need to go through the training before they can go out?
Good question. So the training is 2 hours long, and it's on October 3rd from 9 o'clock in the morning till 11 o'clock in the morning.
And do they come to this office?
They do. They'll be here on 1300 17th Street, room B1, or 1B.
1B.
B is in boy,
All
I
right,
love
so
to
there's
read.
the graphic right there. So
it
it's the corner of 17th and L, 1300 17th Street. Downstairs, room 1B, big conference room, and the reason you need the big conference room, I'm anticipating, is because you'll have a lot of volunteers that may want to help out with this. Have you ever had college students want to volunteer to do things like this?
I have not. This is my first time doing the community reading project. However, before I started the program, before COVID, there were college students that were involved as well.
Well,
which
you
I
know
think is
what?
phenomenal.
I've got an
Yeah.
idea for you, because I think we have an inside with somebody with CSCB Athletics.
Wonderful.
And we'll talk to them and see if maybe some of their athletes would like to go and possibly help out with the reading project.
That's perfect. We'd love to have them.
Do you remember any books that have to tie with literature and mathematics?
No. My sister might. She's a math teacher.
She's a math teacher. All right, so here's what I want you to do. Part of your homework, Ryan,
Okay.
is I want you to talk to your sister and talk about any books that would be second grade appropriate,
Okay.
and see if any of the instructors would be willing to tie some of those into, because as the student is reading, they can also be learning some mathematical concepts.
Okay.
I know a lot of times reading, you know, it might be fantasy or things like that, but they can also read to gain knowledge at the same time, right?
Absolutely, yeah.
All right. Anything else we need to know about this before we let you off the hook? I know
think
you got to
we
get back
covered
to
it.
work and
We
stuff.
covered
so.
it, yeah. I'm a busy man too, yeah.
Yeah, there
We
you go.
covered it.
Right.
Thank you.
Well, Ryan, we'll let you go. Thank you
for
for
being
stopping in. That is today's Math in the News. Hey, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. 636-4357 is that phone number. And don't forget, if you phone in to do the math today and we do one of your math problems on air, you'll automatically receive yourself a pass to the Kern County Fair. And the Kern County Fair opens today. And that is open for, I believe, the next week and a half. So if you'd like to go to the fair for free, save your parents a little bit of money, all you have to do is call up. If we do a math problem with you, you're going to the fair for free. Right now, we'll check in with the kids at Science for Kern. All right. Thank you.
Hi, I'm Sam, and today we have Justin here for Science for Kern, and this is our first series of several science projects or challenges we'll be doing this year. So Justin, tell us a little bit about what Science for Kern is.
Well, Science for Kern, one thing we're excited to be back on Do the Math. We've got now more students, we've got a live audience. It feels like I'm Bob Barker here. But Science for Kern is a great way, because one question teachers always have, how can I get students more engaged in science? And is there resources available? Well, Science for Kern has kits that teachers can check out from 3rd to 5th grade, standards aligned, that come with all the materials, the lesson plan. It's ready to go. So you take it in your classroom, undo the box, and you're going to have an engaging science lesson. So this is based upon one of our kits, which is a STEM engineering design kit. And this is an engineering design lesson. So today what they're going to do is that they are going to be engineers. Science has two different things. We have the science, how do things happen, why do things happen? Then we have the engineers, they solve the problems once the scientists figure out the answers. Okay, so we have a bunch of engineers here today with all of our students, and what they are going to do is they are going to build a tower. But unfortunately, they only have a couple different materials. They have spaghetti noodles and marshmallows. So sorry kids, this is not an early dinner. This is your building materials. Here's your goal. If everyone can look up there, you have the engineering design process. What do you notice about that? What's in the middle of that engineering design process? Go ahead and say, yeah, it's a circle. Here's why it's a circle. It never happens the right way the first time, and engineers know this. So you have to keep going over and over again. So what we're going to do is we're going to do our first build. Here is your challenge. We have your materials. You have about 5 minutes. You are going to build the tallest freestanding tower. Freestanding means what? Yeah, your partner can't be there trying to hold it up just to say it's there. It has to do it all by itself. It's going to be freestanding at the end of 5 minutes. Who thinks they can do it? Oh, look at that. The excitement is contagious, everyone, bunch of engineers. Are we ready? Yes. Open your bags and start building. Go.
Good job.
Well, first engineer problem. Our bag's too small, huh?
Good job working together.
So the big marshmallows are popular. And remember, you only have 5 minutes. So this is going to go by quick. There's no time for permits or planning commission on this one. You just have to build.
And do they get 2 tries?
They will, yes.
Yeah.
So this is their first try. Okay, I'm starting to see the formation of a tower.
Oh, okay. Square, triangle.
Think of famous towers that you've seen. We know of all those towers that are.
There you go.
popular with the young kids.
Looks like those guys are off to a great
They might
start.
want it to lean.
So Sam,
that
we're going to
much,
check in
but-
with you guys in a few moments and see how they're doing and how they did with their towers. But look, what do you think? What would your strategy be if you had to do that? You had some spaghetti and some marshmallows. Do you have an idea what you would do for a base?
I'd just make like a spaghetti, marshmallow, spaghetti, marshmallow, and then make another spaghetti. I'd just like build up from there and then just close it.
All right, so we can see some of them are doing what you're talking about, but I saw one student right there, they were working with a triangular base. Now that's a little different because they've got 3 legs just hooked to the marshmallows, but you see how that one's a little different? Where they've got
Yeah.
spaghetti in between the marshmallows? Do you think that would lend more support doing it, or just having the spaghetti into the marshmallows itself?
I think it would have the spaghetti and the marshmallows would have a little bit more.
And it's going to have a
support.
little more support.
Yeah, because you're sticking it in, and it'll stick better.
Right, and one thing I want you to do, if you ever get bored sometime and you might just want to look something up like that, look up the difference between a triangular base and a square or rectangular base, and see if you can find out which is more structurally sound, shall we say. All right, because a lot of times kids are like, well, I thought it would be the other way around, but a lot of times, if you look at a lot of buildings and the structures and the skeletons of buildings, you're going to notice one shape a lot more than some others.
Yeah.
Anyway, you ready to do a little math today?
Sure.
All right, so we were talking a little bit earlier, and I had asked you if you were confident about something, and you said, what % were you sure of something? Do you remember? You were like, I'm 101%.
Oh yeah. I'm 101% that I'm gonna do good on this math.
There you go. All right, so 101%. So can we ever get higher than 100%?
No.
In some cases we can, right? But when you're talking about, I'm going to give it
Well-
my all,
Yeah.
you're going to give all your 100%, right? Because that's all
Yeah.
you have to give, right? Now, there are going to be times when I go, I want your all and her all. I have 200%, 100 from each of you, right?
Yeah.
And we can do things like that. I made 200% profit on something.
Yeah.
So a lot of times you hear people go, I want 110% from you. Well, I can give you 100%. I don't know where you're getting the other 10%, but I'll give you my 100%. That sound like anything you've ever heard?
Yeah, a little bit.
Okay, so here's what I want you to do. Go on over to the board. And I would like you, Luke, to select a number between 1 and 25.
16.
16, so right on the board, 116%. You're going to give 116%. Good, I'm glad you put the percent symbol up there, otherwise it's going to be 116 something. So Luke, what I'd like you to do is work with Cece, and we have that number written as a percent. I would like that number written as a decimal and as a fraction.
So since you're 101% certain you know how to do this, I'm just going to stand here and let you go.
Okay, so one whole, 100% would be 1.0 and rest, but we have 116. So instead, there's got to be something here, and that's going to be the 16. So it's going to be 1.16%.
Careful, because you had it as a percent here. When you did the 1.16, what was it? Was that still a percent? Or,
No.
Yeah, that's just the number, right? So you can
it'd
erase
just
that.
be-
Yeah. Good. Okay.
Yeah.
So we've got it as a decimal, and now what?
Fraction
Okay.
would be, so if we had 52, it would be 52 over 100, because 100's like out of 100 is what we usually do. So we'll have to do this number over 100, which would be 116 over 100.
Okay, right, yep, because 100 is what percent means. It means out of
Yeah,
100.
out
That's
of
good. Okay,
100.
perfect. Now, am I going to leave it like that?
No.
Why?
Well, because if we have,
Just looking at the fraction, should I leave my fraction like that? 116 over 100? And I don't?
no, we
Okay.
want to make it a mixed,
We can, but what else can we do to it?
we could make it,
Have you simplified fractions before?
yeah,
Yeah.
so we could make it,
Well, if you want, do
Do
you
we
want to
wanna
make it a mixed
simplify
number
it then?
first and then simplify it? Or you can simplify and then make it a mixed number,
Yeah,
either way.
yeah, right,
Whatever
yeah.
way is more comfortable for
Yeah,
you.
whatever works.
So
You
we
decide.
could make a mixed number by,
Okay.
it's already over 100, so we have 1, and then we have 16, 100.
Okay, good.
And then to simplify it, we could just do like something that could be divided by this that could also be divided by this.
So if we're looking at the 16 and the 100, what numbers could?
We could divide by 4.
Oh, okay.
And this would be 4. So
And the 100 would be?
25.
Okay, so let's go ahead and write that one down at least, and then we'll talk through if we need to do anything else.
425.
But don't forget you had the 1 whole, so we're going to
Yeah.
have, 1
The
whole
1.
and then the 4/25. Okay, are we done here? Can we simplify that any further?
We can't.
It's okay. It's a trick question. Can we simplify it any further?
No.
No, you're good. Okay, yeah. So we can leave it here, and that's fine. Yeah.
Yeah. That's the most we can simplify that.
Okay.
All right, there you go. So you've got the percent, you've got the decimal, and you've got the fraction, and you've got the fraction simplified. So you left it as an improper fraction first, and there's going to be times in junior high school and high school where you want to leave it in that form.
Right.
But it's always good to be able to simplify if you can at all. 636-4357 is the phone number. For some great work so far today, Luke, you've got yourself a couple of passes to any CSUB athletics event that you would like to go to. So is there a favorite sport that you like to go watch?
Basketball.
Basketball. Well, guess what? Basketball season is coming up at CSUB. You've got yourself a couple of passes so that you can go either see the men's game or a women's game, or you can use your passes, go to the men's game and go, hey, this is pretty fun. I want to go to a women's game. Check that out. And if you want to win more, all you have to do is call Do the Math. We'll help you like that. All right? Hey, we're going to check out some work with manipulatives and pattern blocks.
Hi, I'm Marylou Long, and today we're going to explore pattern blocks. Believe it or not, pattern blocks is a great tool for teachers and for students for that conceptual understanding. When students are in TK, they're really learning about patterns. And so just simply using patterns, we can kind of start seeing colors. We can start separating by shapes. When we move into kindergarten, students are learning how to count, and that's called cardinality. The amount I count is the amount I remember, 1, 2, 3, 4. Also, what we can do is we can just put out some pattern blocks and allow the students time to count the way they want to count. How do they want to sort? Do they want to sort it by shape? Or maybe they want to make a pattern. Maybe they want to sort it by a pattern, A, B, C, A, B, C. In TK through 2nd grade, we do what's called additive thinking, where they're really making sense and trying to put together those patterns and learning to add and subtract. When we're getting into the other grades, when we're getting into 3rd grade, we're seeing that this repeated addition is now really turning into multiplication. Here I have 1, 2, 3, 4, right? So I have 4 groups of 1, and 4 times 1 we know is 4. Or we can break this up into groups. Here I have repeated addition, and I have 2 plus 2 plus 2 plus 2, or I am seeing 4 groups of 2, which I know is 8. So now we're into multiplicative reasoning and really trying to understand what that looks like. When we're getting even to the upper grades, we're going from that multiplicative reasoning into proportional reasoning. And what does that mean? We really need to understand what those equivalent fractions look like. If I said that these 2 shapes equal $36, how much would this one shape equal? So when we break this down, we know that each one of those equals 18. By putting both of these on, we know that these 2 have to equal 18, as well as these two shapes need to equal 18 because we know that 18 plus 18 equals 36. So then what does one trapezoid equal? Well, I know that 9 plus 9 equals 18. So therefore, this one trapezoid needs to equal 9. So I know that both of these equal 36, and I know therefore that this one shape equals 9. What does this rhombus equal? Well, let's break that apart again. I can break it this way, where I see 3 rhombuses equal 1 hexagon. So I know this one hexagon again is 18. Well, now I have 3, and I know 18 divided by 3 is 6. So therefore, I know this one needs to equal 6. So I have 6 plus 6 plus 6 is 18. I could even break that down further, and now let's look at this with our triangles. So breaking it down, how many triangles do we now have? I know that 2 triangles equals 1 rhombus, and I know the 1 rhombus is equivalent to 6. So therefore, I know that 3 plus 3 is 6, so each one of these has to equal 3. So just understanding what that proportional reasoning looks like, starting in TK, making sense of patterns, going into that additive thinking, and then moving into our proportional reasoning. Eventually, when we start 8th grade, we're now going to get into functional reasoning. And how can we use these with functional reasoning? That is something I'm going to leave with you to think through. How can we continue to use these as teachers? There's so much we can do with pattern blocks. Get a set, check it out. It's lots of fun, and your kids will absolutely love it. Thanks again for joining me today with pattern blocks.
Always a lot of fun things you can do with pattern blocks, regardless of what age or grade you're working with, because Cece was just saying, oh, that's what they use pattern blocks for in lower grades, because you can use them in high school. Have you ever used pattern blocks in any of your classes?
Yeah, I use them a lot.
Do you still use them, or
No, we don't use them in classes anymore, but like in first, second, and third grade, we'd use them a lot during like just when we want to show how we did like fractions.
Okay.
Sometimes we do them in like 4th and 5th for fractions too.
Well, good. So there you go. Another example of using pattern blocks all over the place.
There you go.
All right, right now we're going to go back downstairs, check in with Sam and the kids at Science for Kern.
All right, we're back here with Science for Kern Challenge, and Justin, let's check in with these kids. They've been doing a lot of building.
Yes, they were doing a lot of frantic building. I gave them 5 minutes, no planning time, and not the best materials. So we had our first time, and now we have a couple teams here to kind of describe what they felt went right with their build and where they thought they could make some improvements on the next one. So we have our 2 teams there. They've made their names. We have Team Skittles on this side, Team M&M's on this side. It's the battle of the candy giants. Looks like we'll need to travel to the dentist afterwards. But let's start with you, Team Skittles. So your build here, what do you think went right with this build?
Well, the base, it stands up. It's pretty sturdy. It won't really fall over.
Okay, so did it stand the way you wanted it? Is this what you had in your mind when you first
Yes.
started building?
This is what I kind of had.
Okay.
Like this type of base.
And how about yourself? Did you, kind of as you both were building, is this what you thought of when it ended?
Sort of.
Okay. What would you feel like something you could improve with?
Well, we were doing it, we figured out that we can't build more than 2 of straight noodles up. So we'd have to keep it 3D.
Ah, okay. So it can't just go 1 and 1 and 1, keep going up like an antenna. Perfect. Good job, Team Skills. Team M&M's. We see here, we have a lot of spaghetti noodles and marshmallows. What went really well with your first build?
The base was strong and sturdy, like he said, and the marshmallows could like stand up until we put a lot of weight on it.
Okay. And then next time, because you'll get another chance to build this, any improvements that you can think of right now with you and your partner?
Like maybe like
The middle base could have been stronger.
Okay, so coming up out of the middle, you started with a good base. Now, as you're coming up, working on that area up there. Okay, so what they are going to do now is that they have the time to go check out others' works, and this time they're going to get a chance to make a plan. So when we come back, we'll see what sort of plan they can have to improve their tower challenge.
That downstairs, guys, and it's cool that they can go and check on somebody else's plans to see what they've done and maybe get a couple of ideas and incorporate those into their plan. Do you think anybody's going to get anything very tall down there with this thing?
Probably not.
Probably
no.
not. Why?
Well, you're giving spaghetti noodles and marshmallows. It's not like it's going to be this tall.
Yeah, I mean, well, they could, right? We'll see what happens. I mean, because you would think, all right, you're sticking it in marshmallows. They're not that sturdy unless they're stale. And the spaghetti, you're going to have to hope that it doesn't break or snap.
Yeah.
Right?
That would happen a lot.
All right. Well, at least you're thinking. You ready to do some more thinking?
Yeah.
Back over to the board, young man. Here we go. I've got a sweet problem for you. Do you play video games at all?
Yeah, a little bit.
Have you ever found that some that are old and you want to get rid of them?
Yeah.
All right, well, that's what we're going to do right now. A video game store was getting rid of old video games. They're going to sell them. They're going to sell 5. So you can write down any information you want. They're going to sell 5 for $102.05.
Was it 5 cents?
So they're going to sell 5 games.
Okay.
And they're going to sell them for $102.05.
And 5 cents. So that's showing 50 right now. So let's change it to 0.05.
Yeah, you can just erase that 5 and put. There you go. And then leave your $sign on the other side. There you go.
All
Sweet.
right.
Now, if they sold 3 games, how much would they have made?
So if they sold 3, so it depends on how much each game costs, and we could multiply that by 2 and then take away from that, and that would be this answer. So 5 times 10 is 50, so 5 times 20 is 100. That's some of what it is. And then we have 2.05, which we already have 20, would go into about another half, so it'd be about 20.5, but there's a 0 right there, so that
So you're really breaking it down. You're taking the 100, and then you're taking the $2, and then you're taking like the 5 cents. Okay, that's how that works.
I was going to say, it's wonderful estimating right there.
I know. So then, so if we're going to go ahead and just actually do this, so that's your estimation, because that's great. Because if you go into a store and you're just looking at pricing real fast, you're just going to want to be like, I want to be able to estimate it pretty quick. But we want an exact answer on this. What are you going to do?
So the 105.
If you want to set it up like a division problem, you go crazy. Go ahead and do it on the board. It's fine.
Okay. So you bring this up.
Okay.
So it can go into can't go into 1, but it can go into 10. It can go into 10 twice.
Oh, up there.
Oh, sorry.
Okay.
And then
There you go. Oh, that's okay. You can also just use it like an eraser. There you go. All right, good.
okay, so then we times it by 2, and we get 10.
Okay.
Then we subtract, and then we get 0. Then we have to bring down. So we bring down this, and we get 2.
Okay.
But it can't go into 2, so we have to put 0 here. So we
Nice.
get 20.
All right.
Then we have to times 0.
Okay.
Then we get 2.
Okay.
Bring that down.
Okay.
And then 5 can go to 20 4 times. So we have to put it behind the decimal.
Right.
So it's 5 times 20. 20.
Okay.
That's 0. Then we bring the 5 down. It can go into 5 once.
Perfect.
Then we get the 5, and this is the final.
Okay, so what is this number, the 20.4 or the $20.41? What does that actually mean to me?
It means 5 divided by 102.
It does. And now in context of the problem, what does this number mean to me?
It means how much much money each game is.
Each game. So one game, for every one game is $20.41. So we
Yes.
said we were going to do 3 games. So now what do we do?
So 3 is 2 times less than 5.
Okay.
And so that means we have to double this and take it from that.
Oh, so you're going to go ahead and take away the 2 instead of going ahead and multiplying by the 3 to get my 3 is going to cost me. Complex
A whole
thinking
new
going
way
on
to
there.
do
I
it.
mean, there are a lot of ways to skin
Right.
this cat.
I would have never thought about doing it that way.
I just would have multiplied the 3, which is absolute. But however you want to do this, you're good to go.
So we have to do 20 times 2. So this is 2, 8, 0, 0, 4,
All right.
82.
So that represents the 2 that they didn't sell, right?
Yeah, that represents. So that means we
Okay.
have to take it from this.
Okay.
So we get 102, row 5, and 40.82. We subtract that, get 3. We'd have to take away from here to get here. So we have 1. We get 10.141.
Are you sure?
That's not right.
You're
No,
fine.
you're fine.
So
There was
leave
just
your
one-
23 cents.
Yeah.
So 3, we can just keep this.
There 2.
2
Yep.
dot.
You're
That's a
1.
1.
Yep.
So 1.
Uh-huh.
But yeah, we have to take away
There
from
you
that.
go.
Sorry. 61. That would be how much?
Nice. And I think at some point you probably would have looked at your answer and been like, wait,
Yeah.
that's more.
I
That's not
saw
right.
it. I saw that soon because I kind
Yeah.
of accidentally.
Yeah, so that's a
switched
great
over
way of
to-
solving that problem right there.
Yeah, all right.
That's awesome because Cece and I mean, we were looking at that like there's an easier way to do
Yeah.
it, but it's just the way we would have done it,
Right.
not necessarily an easier way.
Right, exactly. If your brain works that way, that's easier for you versus
Bottom
easier for
line
me.
is get the problem right.
There you go.
All right.
Got
In
it.
studio with us right now, we have Kyle Conder. How are you?
Hey, Mike, how are you?
Excellent. Thank you for coming in. I know you're a busy guy. You are the Director of Athletics for CSU Bakersfield.
That's right.
And you're relatively new to the position here also, right?
Well,
But you've been here, I mean, has it been like a year?
Approaching
Okay.
a year. Not quite.
Because I remember walking into a restaurant over at the marketplace, and I saw the old athletic director, I think maybe was with you, or Dr. Wallace, or somebody was with you.
Yeah, we had a
And
couple
I was like, I
VIPs from
knew
the
they were looking
university.
for a
Yeah.
new athletic director, and I was like, and I think I just kind of hey, really introduced myself kind of
Yeah.
quick, and hey, nice to see you, whatever,
That's
who
right.
knows if you're going to get the job or not.
Yeah.
Because I don't think they had named you yet.
Not yet.
At that
No.
point.
It's the start of a beautiful relationship.
There you
though.
go. You've been named, though.
Yeah.
Tag here written now, right?
That's right. That's right.
So let everybody know, because you are the first athletic director that we've had on the program. We've had President Zalesny and Horace on before that, a lot of professors, a lot of athletes on the show, but the first athletic director. So what does an athletic director do kind of overall at a university?
Well, you wear a lot of hats as the athletic director. So Cal State is a NCAA Division I program. It's the highest level of intercollegiate athletics. We have 16 varsity teams. We have about 300 student athletes, about 90 coaches and staff. And so it's a big enterprise. We've got a lot of moving parts there.
I was going to say, you have a lot of people to kind of oversee.
That's right.
And all of these student athletes are kind of like your kids while they are at CSUB.
Very much so. It's a pretty unique population. It's definitely student and athlete. We use that term intentionally. Student comes first. One of the things we talk about a lot in our program is these hallmark of 4 pillars. They
Right, I was
really
going to say
are-
the 4 pillars, because this is something that you're trying to get the community involved with also.
That's right, yeah. So the foundation of our program, these 4 pillars, are academic excellence, an outstanding student-athlete experience, competitive success, and then community engagement.
Now, you wear many hats. One of them is hiring. So is this hiring, because when people think about the athletic director, they probably think only of coaches. So it is that, but are there other people you are overseeing as far as hiring?
Absolutely, yeah. So you mentioned coaches. So we've got a number of new coaches throughout the spring and summer. We've hired a new softball coach, a new golf coach, a new women's soccer coach, some others. But like you said, there are people in the department that kind of keep the trains moving on time, that make everything work. And so whether you're talking about marketing or academic advisors, our compliance staff, our sports information, people that work in public relations and game management and those kind of things that you help us out with from time to time. Like I said, there's a lot of people that make our operation go.
And I know that a lot of funding is a big thing of yours. And it seems like, all right, so every once in a while you'll see students with the uniforms on, and there are different brands on the uniforms. So you're in charge of getting the equipment. If there's a new sponsor, does it necessarily mean you need new equipment, or can you still use some equipment? And how big of a project is that for you to just make sure you have all the proper equipment for all the different sports? Because you have 16 different sports.
That's right. That's right. And it's a good question to ask, because we might work with an apparel provider, for example, who will outfit our teams and their uniforms and the shoes that they might wear. But then, like you said, the equipment that we use for the baseball team is not going to be the same things that we use for the soccer program. And even a sport like softball is going to use different batting gloves, and a softball is different than a baseball. So we have a different provider who will provide us equipment for all the different sports.
So I know we're going to go on to something else, but as far as we're on equipment right now, because I help you guys out with some baseball and stuff like that. A baseball is it worth about $9? Am I close?
That's about right, yeah.
Okay,
yeah.
because when they hit foul balls, they like them to come back.
Right.
Because that's $9 for every time a ball gets hit, and it may just be in play for one pitch and then it's gone.
That's right.
So that's a lot of money, and I dare say some kids might want to go out to a baseball game sometime and count how many foul balls. That's how much money is just leaving.
That's right. And so one of the promotions that we'll do a lot of times at Cal State baseball games is if there is a foul ball during the game, if you go and collect it and bring it up to the press box where you're there, then we'll give you a free meal, or we'll give you a little voucher where you can go to a local restaurant or a local vendor and get something with a gratuity.
And that ties into marketing that you do at the university also. So tell us a little bit more about marketing as far as where you are coming from.
Yeah, well, again, I think it ties back into that community engagement piece. So from time to time, you'll see that we'll advertise throughout town using different billboards or radio, TV ads, those kind of things. We want our brand out there. We want people to know who Cal State is and what's happening with our program. And we think of ourselves really as the front porch to the university. So if you want to know what's happening in the math department or engineering or the music department or whatever the case might be, then we like to use athletics as a way to draw people in.
And this is the only university in this county.
We're the only four-year Division I institution within a 100-mile radius. So we really feel like not only are we the university for Bakersfield, but we're the Division I athletics program for all of Kern County.
Right, and this is the size of a lot of states back east.
That's
right. I know you came from Texas, and you're
That's
like,
right.
well, yeah, Texas is pretty big and stuff like that. But I mean, if you take a look at Kern County, you are the university basically for the size of a state back east.
That's right.
And you want to get people involved with the university more and more, let people know what is right here instead of having to go someplace else, everything that you have to offer here.
That's right.
So I know you do a lot of budgeting and things like that. Talk a little bit about fundraising, some of the things that you do at Cal State that other universities probably do, and some things that may be a little unique to CSUB.
Yeah, so part of it is what you described in terms of our location and where we fit into Bakersfield and Kern County. We're in the Big West Conference. That's the league that we compete in. And a lot of our schools are in big cities, and their student population are tens of thousands. Cal State, we've got about 9,000 to 10,000 students, so it's a pretty intimate campus. Again, Kern County, we've got about 1 million people, and in Bakersfield, there's about 400,000. So we really are, again, a reflection of our community. We're excited that we have rebranded our fundraising under the Roadrunner Club. It's something for people who have been in this community for a long time. They might remember this was basically the original booster club was the Roadrunner Club.
Right, back when CSUB started. And
That's it.
was
so-
D2 and now going to D1. You
And-
want to be as successful now.
That legacy of success is something that, again, we really want to celebrate as we make our mark now in Division I.
All right. You do a lot of math all day?
We do our fair share of
I was
math
going
in
to say,
athletics.
you must be
That's
doing
right.
a lot of math
Yeah.
because kids think, well, just go out and watch the sports and hire some coaches and go watch some games and stuff like that. But there's a lot of stuff that goes on behind that, and almost chameleon-like
That's right. That's
duties
right.
that you have to do
Yep.
with the man in many hats. Anyway, Kyle, I know you're a busy guy.
appreciate it.
Thank you for stopping by and sharing your expertise with us about the athletics department at CSB.
Absolutely.
And hey, if you'd like to win some passes to any CSB athletics event anytime during the season, all you have to do is give us a call. We do your math problem, and you're going to see basketball, baseball, who knows, right? Runners
right.
on, right?
Go Runners.
Runners up. All right. Hey, you know what? We'll be back with more right after this.
Welcome to Cal Poly, a distinctive, world-renowned university located in San Luis Obispo, California, and founded on one principle: learn by doing. For more than a century, we have proven that the most effective way for students like me to learn and grow is to jump right in, head first, and hands-on. And while we're known nationally for our engineering, agriculture, and architecture programs, learn by doing experiences mean that our students excel in every discipline and every one of our 6 colleges. Mustangs are uniquely positioned with the skills to shape the future of California, and when you help shape California, you change the world. It's one of the reasons we've been named Best in the West for 30 years and most innovative school in the West among public master's universities. It's why this year we're able to recruit our most academically accomplished, most diverse incoming class ever. From our first days on campus, every student engages in an all-encompassing learn-by-doing culture that you just can't find anywhere else. From co-authoring peer-reviewed, faculty-led research to pursuing passion projects that connect their areas of study to real-world needs. Selena's son chose Cal Poly not just for the computer science program, but for the chance to build something new. Selena founded Slow Hacks to challenge students of all skill levels to use hardware, software, and code to build creative products in one weekend.
I think that hackathons are pretty much an essence of learn by doing. At a hackathon, you spend 12 to 36 hours building a project, which is pretty much what learn by doing is.
Thanks to Selena's leadership, Slow Hacks connects hundreds of students each year and serves as a recruiting event for tech employers.
As for Slow Hacks, I really hope that it remains as a prominent hackathon organization within California and that it's able to positively affect a lot of students around California and around the world.
Real projects with real consequences and real risk of failure. Any Mustang will tell you that is when you earn experience you'll never forget. Zoe Fox was among a team of architecture students who worked with residents of Paradise, California in the wake of the Camp Fire to envision a more resilient community.
This project is learning through service. It's kind of like an emotional investment in your work.
Mustang spent months immersed in resilient design with Professor Stacy White.
Working with a real client is a completely different experience than anything you get from really any other studio. You have to get into the details, like how can this be a real building that can be built and service real people?
On the final trip to Paradise, the teams presented their designs to a community determined to rebuild.
In reflection, I think we're all insanely proud. We've all developed this attachment to the people, to the community, to the project, and finishing is giving them this gift of design, which is the only thing that we can possibly do as architecture students to help this community that's gone through devastation.
Years of learn by doing means that graduates are ready day one to take their future into their own hands, ready to shape their careers, their communities, and California for the better. For NASA astronaut Victor Glover, he took his learn by doing attitude to the International Space Station. While in orbit, he relayed a special message to his fellow graduates.
I want to encourage you to continue to learn by doing. That doesn't stop after you graduate. It sure hasn't for me.
Glover is the latest in a legacy of Cal Poly astronauts. He piloted the SpaceX Crew Dragon and completed 3 spacewalks during his historic mission. Next, Victor could be headed to the moon through NASA's Artemis program.
I want to encourage you to dream big and to be patient and enjoy the journey.
You're now a graduate and member of the Cal Poly Mustang family. Congratulations!
So long for now. Keep shining. Graduates, from up here, your futures look very bright. I expect to see big things from this graduating class. Ride high, Mustangs.
He is one of thousands of Mustangs answering the call, going where California needs them, living a life of learn by doing.
And just a reminder, as we enter our 22nd season here on Do the Math, we do have tutors available for you to work with on Tuesdays and Wednesdays throughout most of the school year. But right now, we're going to head back downstairs and check in with the kids from Science for Kern. Sam, what's going on?
All right, we're back here, and the kids have finished their first build. And now, Justin, what process did they go through?
So we're right in the middle of our circle of the engineering design process. They got a chance to go and actually look at all the other partners in their build to get some ideas. Then they did some research and came back, and they were able to make improvements and actually sketch out what would they want to do on their second build. And Esteban here even said, next time, let's improve and not eat some of the marshmallows. So he's ready to go. And hopefully the other teammates have that as well. So now at this point, they have a new bag with marshmallows and spaghetti noodles in it. They also can use any other materials that they had from the first build, because we don't want to waste marshmallows and spaghetti around here. Okay, so at this point, they're going to get another set of minutes, about 5 to 7, and they're going to rebuild. Are we ready to rebuild?
Yes.
All right, your rebuild starts in 3, 2, 1, go.
Okay, demolition, demolition, demolition.
Trust me, this will be the most important thing ever. Is this like a good size? You want to make it like this size?
Now at this time they do have their plans, so let's see how well their blueprint aligns with their spaghetti noodles.
Do you want to get the new ones?
So what are we starting with here?
So we're thinking like this design right here.
Starting with the base.
We're basically trying to make a square base and like basically support it with X's.
Like through the middle like that.
And I always love when the host comes during a build time and asks people, they're like, hey, you're taking my time to build, right? Okay, let's go get someone else. Are we using the same one as last time? So you're building off of your original design?
Yep.
Okay. So doing a remodel, not a new build. So we'll see how that works
We are
out.
doing the remodel. Just
Yes.
Use our whole build.
Perfect. Because you liked your base last time, right?
Yeah, a lot.
So you're just going to improve off that. Very nice.
This base is weaker, but it will be stronger.
And Team Skittles here is using their same build as well. Okay. What improvements are you going to make here? What are you trying to build?
He's gonna build a bottom base.
Okay.
This is gonna go on top of all that.
Oh, so now that, your original base is now going to be your top at the end.
Yes. I'm
Okay.
gonna put a marshmallow up here to connect it all.
Very nice. And I see also here, the original base had the small marshmallows. Why'd you choose to do the big ones?
It's to weigh down because this is a lot of weight we're gonna add onto the top.
So stronger foundation with the bigger marshmallows?
Yeah.
All right,
And it's
perfect.
a lot heavier.
Looks very nice. Can't wait to see the final one. And now here we have a wide base. This thing's ready to hold some weight, huh? How many levels do you want to go up? What's your plan?
Really, how many levels there are possible?
Oh, no, the sky's the limit.
Yep.
There is no ceiling. Well, there is a ceiling here, so you can't go higher than our actual ceiling, but can't wait. And how about here? I'm seeing, so you're going with a lot of noodles.
Like a 2-layer.
Okay. So you decided, let's put more noodles in there.
Yes.
Very nice. And are you able to distinguish the noodles you're building with and just the noodles on the table?
Yes.
Okay, good. That's better eyesight than I have. And is yours going in the middle? Because what is your partner
His
building?
is on the bottom.
Okay.
And mine is going to be
All right.
on top.
Well, let's pause here. We'll let them keep building, and we'll check back in with you, hopefully with all the finished products, and see whose was the tallest.
Commercial break.
Back to you, Mike.
Back in with you guys in a little bit. Like they're doing some outstanding work right there. And Luke was commenting on how when they were putting a couple of those spaghetti sticks together, looked a little more reinforced, right?
Yeah, it looked like it would be more sturdy and that it wouldn't fall apart. Like if one stick broke,
You
there'd
got
still
some
be a
others
lot
right there,
more,
right?
Yeah.
All right. Hey, you know what? I'm going to give you a challenge. I want you to do a problem in a minute.
Okay.
Head on over. 2 over 3, 2/3,
Okay.
times 6 over 8. And there's a variety of ways you can do it, but you've got about 45 seconds to figure it out.
Okay, so we have. I'd make the denominators equal. So.
Do you have to with multiplication?
Oh.
You can just multiply right across.
Now
if
you
want.
have to with
Yeah,
addition
you
and
could just-
subtraction for sure, but with multiplication, you're
No,
good,
you could
right?
just multiply right across.
There you go.
I
Okay.
forgot. Okay, so that'd be 12 over 24.
Okay.
So that'd also be, if we simplified it, divide this by 4.
Okay.
Well, actually, we could just say that this is, just erase all of that, and we could just say this is 1/2, because obviously we know.
Nice.
We
I
know
was
if.
going to say, you saved yourself some
Now
time.
it's fine. You could have done the divided by 4 and divide by 4,
Yeah.
and then you would have seen you could do it again.
Yeah,
it's
but-
fun. Very good. Good.
There you go.
But
You
then
met the
you
challenge
just-
right there. There you
There's
go.
1/2.
Nicely done.
Nice.
Hey, we do go until 5:30 as far as math help, but right now we're going to go back downstairs and check in with the Science for Kern kids. All right, Sam.
All right, so you can see we are deep in our build right now. They are improving their design already. We are seeing towers far higher and stronger than we saw the first time, so all that planning really helped out. Unfortunately, they have a few more minutes that we won't be able to show, and our last bit of the engineering design process is that share piece, so we will make sure that we put and share their final product with you. But as you can see already, I think we have future engineers in the building. Here, this one already has it. It has a Marshmallow Wilson on it. He's loving that. And that's not even the base yet. He's still building his strong base. Here they're building strong base. They're getting it ready to go. And then at our last table here, our last team, they're still building, but you can already see they went with their wider base, building up tons of improvements. I gotta tell you what, for little amount of time, it's amazing what they can build and what they can come up with. I'm thoroughly impressed.
All right, so we will be posting these on our social media. You guys can see these towers when you check it out on the Do the Math. Back to you, Mike.
All right, thanks for that, Sam. And guys, with Science for Kern, some kids were doing some great work down there. And like they said, you can check it out on social media and see the finished products down there and see what kind of outcome they had. Did you learn a little something today?
Yeah.
Did you have fun today?
Yes, I
That's
had
the
a lot of
most
fun.
important thing. Are you ready to be an ambassador?
Yeah.
You know what that means?
Like.
Tell all the kids about Do the Math. Can you do that?
Oh yeah.
All right, here's your uniform. Let's take a look at that uniform that you've got. Brand spanking new design this year, new colors. There you go. What do you think about that? Pretty nice?
Yeah, it's good.
Yeah, there you go. I
like
like
it.
it too myself. Not too bad. All right, so you're our new ambassador. You're going to tell kids all about Do the Math. Whenever you have your shirt on, you can tell them about it and tell them how much fun you had, right?
Yeah.
There you go.
Or at school tomorrow, maybe.
There you go. Wear it to school, even better. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.